What's up, everybody? How's it going? So today, little video here. We're going to talk about, yesterday we mentioned describing a distribution. I am going to embed some of that stuff from yesterday in the beginning because, sorry, but period A, right? Like it was a disaster. So you might have to skip over a little bit of the beginning if you're from periods E or H. But that's the beauty of a video. So jumping in. So we're transitioning right from we've been spending a lot of time making graphical displays, histograms, dot plots, stem plots, box plots, and now we want to start to write about those things. We want to start to describe the distribution. And again, right, for some of us, this is a repeat from yesterday, right? So you can kind of skip ahead as needed. But anyways, describe the distribution. So to start, right, I keep saying the distribution. What do we mean when we say the distribution of data? A lame answer probably would be, we literally mean how the data is distributed. Like that's also the real answer. So when we talk about the distribution of a quantitative variable of a data set, how it's distributed, we're saying, all right, if I look at a distribution of data, which I see in a histogram or a stem plot or dot plot, I can see the possible values of a variable. So looking over here, right, for tree heights, right? I don't know the exact values, but I see the possible values. I know the tree heights were roughly from 60 to 90 feet tall, right? I know there were like 3 trees between 60 and 65 feet tall. I don't know what those exact heights were, right? But I can roughly see the possible values of the tree heights or of the variable, right? I can see the frequency of each value, right? As I just mentioned, right? I can see that there were three trees from 60 to 65 feet tall, 10 trees from 75 to 80 feet tall, and so on. And then I can also see where there's clusters or gaps, right? Like here, I can see like kind of the majority of trees are in this middle chunk, I don't know, 70 to 80, 85-ish feet tall. Or thinking about the example from Friday's assignment, I could see that there was a bunch of cereal brands that had low sugar content and a bunch that had high sugar content, not much in the middle. All right, so when we're talking about the distribution of data, how the data is distributed, we're talking about its possible values. We could see its rough max and min. We could see where chunks of data are. We could see where the mode is, and so on, right? So that's what we mean when we keep saying this word distribution. Describe the distribution of blank, of black cherry tree heights, or of monsoon rainfall amounts. Super common AP exam question. The 2019 free response, the first question, part A, was describe a distribution given a histogram. Part B was create a box plot given a table of summary info. And just so you know, part C was what can you see in the histogram that you can't see in the box plot, and vice versa, I think. And those are things that at the end of this week, we could do that entire free response. But the real point was describe a distribution is a common AP exam question. So on your homework or whatever, your independent, your asynchronous learning assignment on Friday, when you describe, I asked you to describe what you saw about sugar content of, I think, 48 brands of cereal or something. And I was just asking you to give me a few bullets. What do you see? What does this graph tell us about sugar content, right? And of course, in the key, there were some ideas. But moving forward, anytime we're asked to describe a distribution, there are going to be now, starting right now, some very specific things that we have to comment on. And we can use the acronym SOX. Some teachers use CUS, right? There's different things we can use. So when we talk about SOX, first up, let's see, we'll go with some blue. The shape. So we want to talk about the shape of the distribution. Is it skewed? Is it symmetric? Is it unimodal, bimodal, whatever? That's the primary focus of this slideshow. The next thing we want to talk about, although I say next, but not really in this order, the O refers to outliers, but it's a little misleading because it's outliers or gaps or clusters, anything weird. You heard me earlier say that some teachers use CUS. They use U here to represent unusual features. So if that works better for you, like do that. I don't care what acronym you remember, whatever is most helpful for us. So shape, outliers, gaps, clusters, or shape, unusual features. Next thing we want to comment on, again, not necessarily in order, but is the center. Now, when we talk about the center, we're never going to say the center is. We want to consider our measures of center. So I'm going quick, but maybe you pause the video and you think to yourself, what are 2 possible, or 3, whatever, what are some possible measures of center we could use? Pause it, think about that. And then hopefully, right, maybe you said mean or median. Mode is also a measure of center. It's not one of our favorites. We'll talk about why. The next chapter is all about these statistics, measures of center and spread, what they mean, how they're affected by different values, and so on. That's kind of getting ahead. So we're never going to say the center is. We're going to reference the mean or the median. Which one we reference is dependent upon what information we have. If we're given a box plot, we can read the median, right? The line in the box. If we're given a histogram, we can estimate the median. It's between blank and blank, but we can't give an exact median. If we have a full data set, we could pop all the numbers, or a stem plot, we could put all the numbers in L1, do the 1-bar stats, and use the mean or median or both, right? So which we use is dependent upon what information we're starting with. And then the last thing, the other S there is the spread. And similarly to center, we're not going to say like the spread is. We're going to provide a measure of spread or variability. And our measures of spread, maybe you pause, think, what could you use to describe the spread of a data set? Our options are the range, IQR, standard deviation. And again, which measures we use are going to be dependent upon what we're given. If I'm given a box plot, I can look at the IQR, Q3 minus Q1, or I could look at the range. If I'm given a histogram, I can give an interval estimate. The range is between blank and blank, or I could say the range is at most blank. If I'm given a full data set or a stem plot, right, I can use any of these things. So there's not one answer. We have to always consider what information we're starting with. So whether you go SOC, shape outlier center spread, or CUS, center unusual feature center spread, right, the order doesn't matter. This is what we want to talk about moving forward anytime we describe a distribution. And in our next class, we'll start to do some of this together. The last thing I'll add is that as we do all of this, everything is always in context. So we're never going to say the graph is. We're not going to say just the median is, like the median what? We're not going to say whatever. There is an outlier at 20, right? Like there's no context there. So we want to talk about black cherry tree heights or monsoon rainfall amounts or sugar contents of cereals. Always, always, always in context. And you'll hear me say that like 700 times. I feel like that should be in font 700. What even, my computer probably just blew up. Anyways, now we want to look at each element. So that caught up some of the other people from before. Shapes. So as we think about shapes, there's two elements of the shape. We want to talk about if it's skewed or symmetric, and we kind of want to talk about the modality. So for us, the mode is more a descriptor of shape. So if I just sketch a quick histogram over here, and I apologize, I'm writing with my mouse, so this is sloppy, right? But like if I see something like this, right? So the mode, the most common data values, right, are in this bin. And so we want to consider the shape, the general outline of the histogram. So something like this. And so for us, the mode connects to the shape in that it creates like this peak, this bump. And as you might guess, something that's unimodal, right? That just means it has one peak or one high, spot in the graph. So we could have a skewed unimodal distribution like I've drawn in blue. So we could have something that looks like this. That's red, not blue. We could have something that looks like this. We could have our classic bell curve, right? These are all things that are unimodal, one peak. Bimodal, as I'm sure you would guess, is going to be something that has two peaks. So the example we saw on Friday, the sugar content of cereals, right? That histogram, and this was referenced in the key, but that histogram was bimodal, right? Maybe we have two peaks, and they don't have to be exactly the same size. Like if we saw something that looked like this, we'd still call this bimodal. Multimodal, whatever, more than two. Maybe we have something that looks like this. We're not going to see a ton of distributions that look like this in our class in AP Stats and Intro Stats, right? But that's that's a multimodal distribution, so just more than two peaks. Sorry, it's kind of going backwards. As I keep drawing all these curves, we're pretending that there's like a histogram underneath all of these, but it would just be an absolute disaster and take forever, right? If I tried to draw the histogram underneath each of these. So as I draw these curves, these lines, these shapes like this, right? We're imagining tracing the outline of a histogram as we did super sloppily in blue and super sloppily in purple. A uniform distribution, right? Think about what uniform means. We wear a uniform. We're all like kind of look the same, right? That's the idea. So uniform has no peaks, or in other words, all of the bins are roughly the same height. And I put roughly in caps there because we're not going to be too picky. They're not going to be exactly the same height. So all bins are roughly the same height. For this example, I'll actually draw the histogram, because if I draw a curve for it, it's just going to look like that, which means nothing. So it doesn't have to be a histogram, right? It could be a dot plot, could be a stem plot. My mouse skills are pretty hurting. Got to run to school and get my tablet or buy one on Amazon, right? But something like this we would call roughly uniform. All these bins are roughly the same height. And so you'll see in your Google Forms practice after this, you're going to have a few questions just describing shapes of distributions. All right, so shape, we got the modality, unimodal, bimodal, multimodal, or no modal, uniform. Next thing we want to consider is the distribution skewed or symmetric? I find it really hard to write a definition of symmetric. I don't know, maybe it's just me. But so if something's symmetric, maybe we have like our classic bell curve, right? We can draw a line down the middle and it's roughly the same on both sides. Or maybe we have something that's bimodal, right? This bimodal distribution I drew earlier. Oh, that was disastrous. Is symmetric, right? We can draw a line down the middle and there, this is roughly the same on both sides. Or even if I draw my uniform histogram, now this one's perfectly uniform. That's not super common, but it could happen, right? That's also symmetric, right? So symmetric, we can draw a line down the middle and it's roughly the same on both sides. Again, I think we have a pretty good internal definition of what symmetry means. We saw the axis of symmetry in Algebra 2 and stuff. But yeah, that's that. One thing I will say is oftentimes we're usually going to be saying roughly symmetric. There are very few data sets that turn out to be perfectly symmetric. So usually we're talking roughly symmetric. Lastly, skewed left, skewed right. So when we're talking about skewness, I'll kind of throw in the middle here in orange. This applies to both. We're going to look at the tail for the direction of the skew. So if we have a data set that looks like this histogram, and maybe we have some small values over here, something, right? Whatever. And we trace this, right? The tail is on the left side. So we would call this a skewed left distribution. In this case, we have a majority of our data, right? We have like more data on the kind of on the right, or in other words, in the higher numbers. And I put that in quotes, right? Because a higher number is subjective, right? That's dependent upon the context, right? Like a 4, that's not good on our first quiz if it's out of 100, but that's a pretty fantastic GPA, right? So what's high, what's low varies depending on what you're talking about. 6, that's pretty big if we're talking about 6 feet tall person, right? Height of an individual, but if we're talking about, I don't know, again, your quiz score, not necessarily a high number. So skewed left, we have more of our data on the right, kind of more of the values clustered on the higher end with a few or some low values. I misspoke. Skewed left, we have a few high values. I'm sorry, we have a bunch of stuff on the right with a few low values. My bad. Skewed left, more stuff on the right, a little bit of stuff tail on the left. We can also call this negatively skewed. Right, we associate negative numbers on the left side of a number line, so you might see someone refer to this as a negative skew. Skewed right, same kind of idea. This time, the tail is going to be on the right side, so for something that's skewed right, we're going to have a majority of our data values on the left with a few high values, our tail on the right side. So for this definition over here, you can say most of our data, or majority of data, or I'll just say lots of data, kind of on the left or in the lower numbers with a few or some high values. So like household incomes in America are skewed right. Most Americans, 99.9% of Americans are towards the left, kind of like middle class and below. And then you got your few billionaires, right, who make us have, millionaires, or rich people who make us look skewed right? Most Americans make this amount of money, then you got some rich people. So I would like you to think about this. Let's say I give our first quiz and I create a graph, right, whether it's a dot plot, stem plot, histogram of our scores, which would make me happier when I see your quiz? Now, side note, the happiest thing would be one bin right above 100. Everyone gets a perfect score. But if that's not an option, what would make me happier? Your test scores are skewed left or skewed right, and why? And if we were in class, I'd have you talk to a neighbor. So pause the video and think about that. Which would make me happy as your teacher? Skewed left, skewed right, and why? And hopefully you don't think I'm super mean, right? I'm a nice guy. I want us all to do well. So hopefully, right, you said that I would be happy if our distribution was skewed left, right? If our distribution were skewed left, that's like most people got A's and B's, some people got D's and F's. That doesn't make me happy, right? I don't want that to happen to anyone. Skewed right, if we looked at, if I looked at some test score data and it was skewed right, that would make me look at my own practice and be like, man, I blew it, right? Because skewed right would be like everyone gets D's and F's, and then like a couple people get A's, which probably means I did a terrible job teaching. So that's the idea with skewness or symmetry. This is like when we're describing shape, this is probably the more important descriptor, skewed right, skewed left, or symmetric. Then the unimodal, bimodal piece, we want to add that as well, but we have to make sure we comment on the skewness or the symmetry if it's there. Okay. That's pretty much it for shape. One thing to think about here is you think about these shapes, think about the different shapes. And this is something we might come back to as a warm-up, but think about what shapes might these distributions take on? The ages of people at a Little League game. If we looked at a histogram or a dot plot of all the ages of people, what shape do you think you would see? Or the number of siblings of people in our class? Or each person's winnings for a Powerball drawing, right? So everyone buys a Powerball ticket, right? Think about how much money they win. It could be anywhere from 0 to whatever, $100 million. SAT scores, or if I kept rolling a die, the number of ones, the number of twos, right? The number of times each face shows. So think about that. I think that's probably going to be our warm-up to start class after this video on Wednesday. Yeah, Wednesday, right? All right. Outliers. So outliers, gaps, clusters. We always want to comment on weird stuff. Sometimes the weird stuff's the most informative part. Sometimes in outliers, maybe just a typo, right? Maybe it's just a mistake. Maybe I hit 100 instead of 10. Okay, now it's a way to check my work. Or maybe everyone I do a bad job teaching a lesson, right? Everyone gets a D or an F. It's that skewed right shape, but one person gets 100 as an outlier. And it's like, oh, what's up with that? It turns out they like have a stat tutor. So right now, that's one of the really informative parts of my data. Hey, the only person who got an A is the person who got an outside tutor. I need to revisit my practice and do a better job teaching next time. So outliers aren't weird things we want to ignore. They're weird things we want to address and investigate and try to figure out, why is this data value so different than anything else, than the rest? We always, always, always want to comment on anything unusual we see in our distribution. I mean, clusters aren't really unusual, so that's kind of misleading. But so if there's any gaps in the data, why? Why is that the case? Why weren't there many cereals whose sugar contents are in the middle? Clusters, right? Why do we have a bunch of cereals with low sugar content and high sugar content? Right, and as I've kind of already referenced the outliers. So to wrap up this video, right, in center and spread we saved for class. When we talk about outliers, right, an outlier is just an unusual value. One thing we have to consider is if we're given a histogram. So the only way we definitively know if something is an outlier is if we actually calculate the fences to prove that it's an outlier. So if we're looking at a histogram, we can't definitively state that something is an outlier because we don't have all of the data, right? So we cannot actually mathematically prove if some value is an outlier or not. So if I were only given this blue histogram, I might say there's one possible outlier, right? Maybe, or I could say there might be one high outlier, or there's one potential high outlier. But something, right, that kind of qualifies it as a possibility, but not a definitive statement because we haven't proven that. If I'm given a stem plot or a dot plot, I might say just possible outliers unless I actually calculate the fences. Now, when we're looking at a box plot, I don't have to do that. With a box plot, we know definitively if there's an outlier or not, right? When I see that separate dot, I know that that is an outlier. So with a box plot, we know if a value is an outlier, right? With a box plot, when we see that dot, we know the fences have been calculated, and we know for sure one way or another if a value is an outlier. So as we start to do some examples in class moving forward and write about these, we'll see all these different scenarios come up. But the way we write about everything, the way we comment on center, spread, outliers, right, that's going to vary depending on the information we're given, right? Histogram, possible outliers. Box plot, definitively we know if there's outliers or not. Histogram, the median will be between blank and blank. For a box plot, I know the exact median, right? It's right here. Spread, for a histogram, we're going to estimate the range. With a box plot, I can give the exact range or I can give the exact IQR. All right, so as you'll see, the way we address these varies with each situation. If you were like in class and we had class, not period A, if you were in period like D or H, you can stop. Actually, you know what? I'm gonna stop now for everybody. That's it. So after this, you guys have some practice in Google Forms. Look at some shape stuff, some estimate median stuff. And then next time I see you guys, we will wrap up any generic notes and start to describe some distributions with histograms and box plots. So until then, have a wonderful day. I'll see you guys tomorrow.